Hello, this is the ZK-SJ30. It's kind of the big brother to the SJ20 that I looked at some time ago. It's a buck boost converter, potentiometer control, but with a little digital display for voltage and current, based on the LT8705. So the SJ20 is a 20 amp, I assume 20 amps in, 20 amps out. Yeah, being a buck boost, of course, this can have the same voltage on the output as the input if it's sort of midway between buck and boost. So 20 amps in, 20 amps out. This one is 30 amps in, 30 amps out. Which is interesting because if you look here on that connector, it very clearly says 10 amps. So the connectors are only rated for 10 amps. And similarly on the SJ20, you can see the same connectors are used, 300 volts, 10 amps. Now I've actually got two of these things because I did that usual AliExpress mistake of ordering the cheap one and that was the one without the display. So I got the one without the display. And then I thought, no, I need the display, and you can't buy the display on its own. So I ordered another one with the display, and you know, it's $30. This one, I think, $40, something like that. And I didn't have a very good start with this buck boost converter because when I received it, I put 13.5 volts on the input. I started twiddling the CV pot just to watch the little green LED, yeah, the out LED down there, go bright and dim because it's simply strapped across the output. Suddenly then it went really bright. There was a little puff of smoke, I think possibly from these two components here. And now I think the chip is dead. So I'll try and show this. I don't know whether you can see, but there looks like there's a slight heat blister down here, and it's right adjacent to the pin, which I think is pin 9, which takes the voltage from this potentiometer, which is a fraction of the output voltage, feeds it back to the chip so that the chip can regulate output voltage. I suspect what happened is that the pot briefly went open circuit because these are not the best quality pots. Guo Sheng, Bo Chen. And yes, I do believe that the chip has died on this unit. Now it's perfectly okay apparently to use this power supply without the display. All the display does is it measures various points on the board and provides voltage readings for the output, the input, the current, which I assume goes through this op amp here to multiply up the shunt voltage, and it also, I think, controls the shutdown pin so that it can switch on and off the output, which of course you can't do on the unit with no display. Okay, let's quickly go through what's on here. There's the main controller chip, the LT Linear Technologies, I think that is, 8705 buck boost converter. It's a 4 MOSFET switching arrangement. Here there's an XL Semi 7015, I think it is. It's just a buck converter, which I think is set to 12 volts because this fan connector says ground and 12 volts on it. Interestingly, the SJ20 unit has the same buck regulator on it, but this one says ground and 5 volts for the fan. So if you want to put a fan on this, and I've mounted it on the underside of the heatsink and lifted the whole unit off the base with a bracket, you have to use a 5 volt fan. Here at least you can use a 12 volt fan, and they tend to be more powerful, or they're certainly available in higher current ratings. Now I'm going to take the heatsink off the bottom because all the high power semiconductors are on the bottom. So apart from the XL Semi buck converter, the main controller chip, the op amp and the current shunt, really the rest of it is on the underside of this unit. So let's have a look underneath. So with the heatsink off, you can see all these MOSFETs, and they are KCB3008B. You can see that because the heatsink compound hasn't thoroughly covered this MOSFET very well. And this is something interesting they've done with the design of this thing. They've put the heatsink so that it touches onto the plastic fronts of all of these MOSFETs. Now that's not the bit that transfers the heat out. That's the tab which has been soldered down onto the printed circuit board. And I have noticed that when this heatsink, when this thing is transferring current, because the second one of these does work, this heatsink doesn't get very warm. So yeah, I don't think these semiconductors are intended to put much heat out of their plastic fronts. Now on the SJ20, they did it a different way. I don't know whether you can see this, but you might be able to just see the MOSFET sandwiched in between the PCB and the heatsink there. And you can see that the plastic front of that MOSFET is pushed up against the PCB, and its metal tab is sitting on a little heat transmissive pad against the heatsink. So these MOSFETs have all been mounted in such a way that the heat is transferred primarily to the heatsink and not the PCB. But on the SJ30, these semiconductors transfer their heat to the PCB, not so much to the heatsink. So when you're running this, it's the top of the PCB around this area, and this capacitor particularly gets very hot, and I think that's because it's sort of on this corner between these MOSFETs. The other capacitors are not affected so much. These are input capacitors. The output capacitors probably have more ripple current on them. But yeah, interesting design that they've chosen to flip these semiconductors over. I mean, it's much easier to assemble this, I presume, by soldering them down onto the board, but then all the heat goes onto the board, not the heatsink. And so whereas I've improved the cooling of the SJ20 by putting a fan on the heatsink, I'm not sure that's the best approach for this one. I don't think actually cooling this heatsink is going to make much difference. Now on this one, I want a solution where the fan is sitting above the board, cooling the surface of the board and these capacitors, which, as I say, get very hot. Also on the SJ20, they've put little standoffs between the PCB and the heatsink, so you can tighten these hard down and you get a good reference between the two, a sort of defined space between the two. On the SJ30, they've not bothered, so when you tighten the screws down, let's find one near the surface there, you can distort the PCB. The aluminium won't bend much, but the PCB can, and that means that it's difficult, or more difficult, to get a precise torque for that screw. The other thing is, on the SJ20 there's a little heatsink just in here, this one at the top here, which draws heat out from the controller chip, the LT8705. On the SJ30 they've not put a heatsink underneath the controller chip. It doesn't seem to get that warm, but it was just a little extra detail that the SJ20 had that the SJ30 doesn't. Okay, let's see it in action. I've made up this, which is lots of these H7 car headlight bulbs. On printed circuit boards, I've put two in series so that I can put up to about 28-30 volts into here if I need to. And on the input side, the most powerful output on a power bank I've got is the 12 volt, it's actually 13.5, 25 amp from a Power Oak power bank. So I will feed that into this unit so I can pull up to 25 amps on the input. Okay, let's power up the power bank, which is here. And this thing comes on. No volts because the output is switched off. This red light comes on when you switch the output on, and no amps. Now I can't remember what this is set to, but it's probably set to something sensible. Let's find out. Yes, that's the other problem. These switches are right down the bottom, and when you press them it pushes this down, but I've started working on that. Now this array of light bulbs is about an ohm. I think actually if I turn the current down to, I think it was 7.5 amps. Why is that not going down? oh, maybe the current limit is set much higher. Yeah, 7.3 or 4 amps, where the bulbs are at this sort of modest brightness. The bulbs are 1 ohm, so you've got the same voltage as current, about, well, similar. You can get it the same, but it takes a bit of fiddling around with. If you turn this right down, then I think it goes to about 0.5 ohm, where you've got twice the current as to the voltage. And if you get them really bright, they're more like 2 ohms, I think, if I remember rightly. Okay, let's have these bulbs in the picture as well as I can. Okay, let's start turning up the current and see how much current I can put through this thing. So that's 7 amps, 8 amps. Now I think the voltage limit pot has to go up. So that's, ooh, not seeing the display very well now, are we? 10 amps at 13 volts. That's current limiting now, I think. Yeah, the current limit LED is this little dim one next to the current pot. But let's turn that up. Okay, 10 amps, 11 amps. Now I need to turn the voltage pot up. So we're up to 20 volts. Oh, you can't see anything. Maybe I'll move this back out of the picture again. We're up to 21 volts. 12 point... now it seems to be limiting. And in fact, a fan has come on my power bank. Now, if we've got 21 volts, 12.5 amps, let's turn that off. Then at 13.5 volts, and of course that will pull down a bit. So we've probably got about 12.5 volts on the input. Yes, that's quite annoying, isn't it? So you can see the input voltage, that's 13.5 volts. If I turn the output on, you can probably see, oh, that's actually gone down to 11.7 volts. So let's call it 12 volts. So if we've got 12.5 amps on the output, we've probably got 25 amps on the input. If this is 12 volts and this is 21 or 22 volts. Yeah, and I got a feeling the Power Oak power supply is probably limiting at around 300 watts. So yes, 21 volts. 12.7 amps is the maximum I can put through this. I don't know where the limit is. I don't think it's this MPPT pot, is it? No, I don't think it's that. It may be a current limit on the Power Oak power supply that's actually supplying this thing. And things are now starting to get warm. The top of that PCB is getting warm. This capacitor I know gets very warm. But the heatsink underneath, that's not even warm. That's cool. These wires are getting warm. And I know that these banana plugs here are not really suitable for this amount of current. And they start getting pretty hot as well. Now, if you press and hold this left-hand button, you can see the output in watts. And let's switch on and see what that is. And it's 270 watts. Now, apparently, if this goes up to 700 watts, there's actually some code in here which will just simply switch off the controller chip by activating the shutdown pin. And now the heatsink, as I say, on the bottom here is not even warm, but the top surface of the PCB is starting to get pretty warm, and these output capacitors, particularly this one, and I think it might be partly because it's heat transmitted from the semiconductors because it's in close proximity to them, but it's also partly going to be because it's having to squish quite a lot of output ripple. Some of these I would have thought as well, but they don't seem to be as warm as this one. And so improving the heat dissipation of this unit, I don't think the answer is to put a fan on the heatsink. And so yesterday I was working on just using a fan grill. This is, I was bending these arms to try and get them to fit these points here, and I bent that one so much it broke off. But the idea is just to put some pillars on here, and of course putting some little pillar extensions on the bottom will solve the problem that when you press the buttons the thing tips over, so you can kill two birds with one stone. But I think mounting a fan on here, and I would just put a 12-volt fan on here, cable tie it to points on these rings, and then connect it into the fan connector there. Now maybe it is a limitation on the power supply coming in. These got warm as well, by the way. But I don't think there's any way I can get this up to 700 watts. I don't think there's any way you could get this up to 700 watts. And in fact, the only way you could do that is if you were working with much higher voltages. Apparently the maximum input voltage is 80 volts, maximum output 78. You'd need to be up in that range. Now, I've got a feeling that this unit died because this pot was a bit dodgy and it suddenly put a very high voltage on the output. So how well protected this chip is against those sorts of high voltages, I don't know. But yeah, I just can't see this 700 watt auto switch off thing being of much use. The SJ20 incidentally has a 300 watt auto switch off, and I don't think I even saw that. In fact, I could put the SJ20 in here just temporarily and see how much current we can get through this one. Right, on the SJ20, I seem to be limited to 9.3 amps, 11 point... Oh, that's suddenly gone much higher. Okay, 11.7 amps, 17 volts. Now, can we go higher than that? No, I think that's the limit. Turning that current pot up and turning the voltage pot up doesn't seem to make any difference. Let's check that in watts. And it's 208 watts. So again, I'm not able to hit this 300 watt limit. I don't think I'm maxing out the Power Oak power bank at 200 watts. So it must be some sort of inherent limit in this unit. The heatsink will get warm, but of course it's being fan cooled. So actually I don't think it will get warm on this unit. So to sum up, this SJ20 with its 20 amp 300 watt limit and the SJ30 with its 30 amp 700 watt limit, are these numbers really to be trusted? We've got 10 amp connectors on the 30 amp unit. We've also got the plastic fronts of the semiconductors attached to the heatsink, which really isn't transferring any heat at all. It's all ending up on the surface of the printed circuit board. So given all these design issues as I see them, I think I would have to derate this unit fairly substantially from its 30 amp 700 watt rating, particularly if you're using it at these lower voltages like 12 volts or even 24 volts. You're not going to get 700 watts unless you're up at 60 or 70 volts. It starts to look to me like there's not much justification for getting the 30 amp SJ30, because the SJ20 can do as much current and power as the SJ30 if you derate it. Enhancing the cooling on this unit is a little bit easier. Yes, you have to use a 5-volt fan, but actually even these fairly low power 5-volt fans, I think these are 100 milliamp and therefore they're half a watt, aren't they? Even those keep the heatsink cool enough that it doesn't get hot. This heatsink will get very hot without the additional fan cooling, but it doesn't get warm at all with the fan cooling. Yeah, I'm fairly convinced that because of the way the semiconductors have been laid out underneath this thing, that additional air cooling has to be done on the top, and therefore you've got to do it with a fan mounted above the board. And I think this pillars and fan grill technique is the only way I can think of mounting a fan on here. Although having said that, I did mount a 12-volt fan. This has a 12-volt fan output there, DC 12 volts. On this, what's it called? This is the D3806 Ming-He, slightly older school power supply, simply by putting a pillar running up there. And then I think this hexagonal shaft actually just pushed straight into the plastic there. So there's a little one of these threaded insert pieces shoved into there. It's quite a tight fit. And then this just tightens up like that. It works fine, but because it's only held in at one point, this is essentially floating over here, because on this one it was necessary to keep this device cool to run this up at the maximum 6 amps. This fan does vibrate because it's only held at one point on the corner here. But yeah, you could use that on the corner of this power supply and cool this area. Yeah, that could work. Just one other thing I noticed, the inductors look very similar on these two units, but on the SJ20 it's triple wound, so it's 3 wires. These are running in 3s. This one appears to be quad wound, so it's 4 wires twisted together, and so they're in groups of 4 as they run round the inductor. So there are probably fewer turns on this inductor. So the ZK-SJ30, I still don't know why this one blew itself up minutes after I first powered it up, unless it's a dodgy pot here. Now I could fix this. I would have to replace that pot because I don't trust it. I think I'd have to replace this chip, and that looks difficult. It would require hot air rework on there, and it's one of these chips with a ground pad on the underside, so that also has to be soldered down onto the PCB. I don't have the equipment to attempt that, so I'm going to write this unit off. I think the way they've done the cooling of the semiconductors by putting this heatsink on the plastic fronts means that it really isn't very well heat sinked. And these 10 amp connectors on a unit that's supposed to handle 30 amps, it's just a bit of a worrying sign, really, isn't it? Yeah, I'm kind of thinking the SJ20 is probably the better choice because of the way the semiconductors are actually mounted so that the heat is transmitted to the heatsink, and the enhanced cooling is a little bit simpler. You just put a fan on the heatsink. You then have to mount this thing up off the ground, but I just drilled some extra holes in this bracket and put threaded screws into the heatsink channels. So that worked quite well. Yeah, I'd say go with the SJ20. At least here with the 10 amp connectors, you're only putting twice the theoretical current through them rather than 3 times on the SJ30. But that's it for this video. Cheerio.